Good day everyone, my name is Kristian Labayno from ECE 3A. Today I will present my performance task number 4 at my ECE 23 subject. Let's start. There are four variations of pulse code modulation: the differential pulse code modulation or DPCM, the delta modulation or DM, the adapted delta modulation or ADM, and the adaptive differential pulse code modulation or ADPCM. But we will tackle only the differential pulse code modulation. This is the differential pulse code modulation. We can see in this picture the quantizer and the predictor. I will discuss it later. But before that, what is pulse code modulation? Pulse code modulation is a method that is used to convert an analog signal into the digital signal so that the modified analog signal can be transmitted through the digital communication network. PCM is binary form so that there will be only two possible states, high and low or 0 and 1. We can also get back our analog signal by demodulation. There are three steps of pulse code modulation: the sampling, second the quantization, and the last is coding. What is? What is differential pulse code modulation? It is a technique of analog to digital signal conversion. This technique samples the analog signal and then quantizes the difference between the sampled value and its predicted value, then encode the signal to form a digital value. The sample of signal are highly correlated with each other. The signal's value from the present sample to the next sample does not differ by the large amount. The adjacent sample of the signal carry the sample information with the small difference. When the sample are encoded by the standard PCM system, the resulting encoded signal contains some redundant information bits. We can see in this picture the bits level and the X and TS. This dot is the time signal. A continuing time signal denoted by the dot line, this is it. This signal is sampled by flat top sampling interval of TS, 2TS, 3TS, and so on, and TS. The sample frequency is selected to the higher than the Nyquist rate. These samples are encoded by using 3 bits or 7 levels. PCM, the sample are quantized to the nearest digital signal as shown by the small circle in above figure. The encoded binary value of each sample is written on the top of the sample. This is it. The above figure at samples taken at 4TS, 5TS, and 6TS are encoded to the same value of 110. This inform can be carried only by the one sample value, but three samples are carrying the same information means redundant. This is it. The samples of 9TS and the 10TS, the difference between this sample only due to the last bit and the first two bits are redundant since they do not change. So, in order to make the process this redundant information and to have a better output, it is an intelligent decision to take a predicted sample value assumed from its previous output and summarize them with the quantized value. What is the principle of differential pulse code modulation? If the redundancy is reduced, then the overall bit rate will decrease and the number of bits required to transmit one sample will also reduce. This type of digital sample modulation technique is called differential pulse code modulation. The DPCM works on the principle of prediction. The value of the present sample is predicted from the previous sample. The prediction may not be exact, but it's very close to the actual sample value. This is the picture of differential pulse code. Predicted signal is indicated by X exponent NTS, and the comparator find out the difference between the actual sample value X NTS and the predicted value X exponent NTS. This is called signal error and denoted as ENTS. ENTS is equals to X NTS minus the X exponent NTS. The quantized error signal QNTS is very small. It can be encoded by using the small number of bits. This is how it looks. The quantizer output would be written as EQNTS is equals to ENTS plus QNTS. The QNTS is the quantization error. Can be written now as ENTS plus X exponent NTS is equals to XNTS. And we get XQNTS is equals to XNTS plus XNTS. Thus, the quantized version of signal XQNTS is the sum of original sample value and quantized error QNTS. The quantized error can be positive and negative, so the output of the prediction filter does not depend on its characteristics. This is the picture of differential pulse code modulation, the DPCM input, decoder, prediction filter, and the output. In the absenteeism of noise, the encoded receiver input will be the same as the encoded transmitter output. The predictor undertakes a value based on the previous outputs. The input given to the decoder is processed, and that other is summed up with the other of the predictor to obtain better output. That means here first of all the decoder will reconstruct the quantized form of original signal. This is the table of the difference of pulse code modulation and the differential pulse code modulation. Each parameter, number of bits, level, step size, bits, redundancy, quantization, error, and distortion, the bandwidth of the transmission channel, feedback, complexity of notation, and the signal to noise or SNR. Let's proceed. Application of DPCM. The DPCM technique mainly uses speech, image, and audio signal compression. The DPCM conducted on signal with the correlation between successive sample leads to the code compression ratios. In image, there is a correlation between the neighboring pixel in video signal. The correlation is between the same pixel and consecutive frame inside the frame, which is the same as correlation inside the image. This method is suitable for real-time application. To understand the efficiency of this method of medical compression in real-time application of medical imaging such as telemedicine and online diagnosis. Summary. What is PCM stands for? Pulse code modulation is a method that is used to convert analog signal into the digital signal so that a modified analog signal can be transmitted to the digital communication network. DPCM stands for differential pulse code modulation, is a technique of analog to digital signal in conversion. Principle of DPCM, if the redundancy is reduced, then the overall bit tray will decrease as the number of bits required to transmit one sample will also reduce. Application of DPCM, it can apply in many ways like in image, audio signal, and medical imaging. Thank you.